Now come to the question number 6. Write tan inverse of 1 by root of x square minus 1 comma mod x greater than 1 in the simplest form. Now we have to write this inverse trigonometric function in the simplest form. Understood, my children? Right. Here also we use substitution technique. Means we have to substitute a suitable trigonometric function to get a trigonometric identity. So to write the given inverse trigonometric function in the simplest form, we are substituting here x is equal to secant theta. If you substitute x is equal to secant theta, we get a trigonometric identity. That is why you are taking here x is equal to secant theta. By implies theta is equal to secant inverse x. Understood this step, my dear children? Right. Now let us take the given inverse trigonometric function. That is tan inverse of 1 by root of x square minus 1. That is equal to tan inverse of 1 by square root of x means here we are substituting the secant theta, so secant square theta minus 1. Understood this step, my dear children? Right. That is equal to tan inverse of 1 by square root of secant square theta minus 1. This is a trigonometric identity. What is the trigonometric identity? Secant square theta minus 1 is equal to tan square theta. So we use this trigonometric identity. So I wrote here tan square theta instead of secant square theta minus 1. Understood this step, my dear children? Right. That is equal to tan inverse of 1 by square root of tan square theta. What do you get here? Tan theta only. So that is why I wrote here tan theta. Understood this step, my dear children? Right. Tan inverse of 1 by tan theta we got here. That is equal to tan inverse of 1 by tan theta. What is 1 by tan theta? That is equal to cot theta. So it is a reciprocal of cot theta. Therefore we can write it as tan inverse of cot theta. Understood this step, my dear children? Right. Again here in the brackets cot theta is there. Cot theta can be written as tan of pi by 2 minus theta. Okay, my dear children. Therefore I am writing here this step, that is equal tan inverse of tan of pi by 2 minus theta, because tan of pi by 2 minus theta is equal to cot theta. Understood this step, my dear children? Right. That is equal to pi by 2 minus theta, because tan inverse of tan theta is equal to theta. This is the properties of inverse trigonometric functions. That is why I wrote this one. Understood this step, my dear children? Right. That is equal to pi by 2 minus theta. What is theta here? Secant inverse x. In the first step of this question, we substituted. Okay, therefore theta is equal to secant inverse x. So this is the simplest form of the given inverse trigonometric function. Understood, my dear children? Right. Now come to the question number 7. Write tan inverse of square root of 1 minus cos x by 1 plus cos x in the simplest form. Here also we have to write this inverse trigonometric function in the simplest form. Let us take the given inverse trigonometric function. Tan inverse of square root of 1 minus cos x by 1 plus cos x. That is equal to tan inverse of square root of, in the numerator 1 minus cos x is there. It is the formula for 2 sin inverse x by 2 divided by 1 plus cos x. 1 plus cos x is equal to formula 2 cos square x by 2. These are the half angle formula. Understood, my dear children? Right. So I wrote here the half angle formula. 1 minus cos x is equal to 2 sin square x by 2, and 1 plus cos x is equal to 2 cos square x by 2. By using these half angle formula, I wrote the previous step. Understood that step, my dear children? Right. That is equal to tan inverse of square root of tan square x by 2. By simplifying the terms, we get here under the square root tan square x by 2. Understood this step, my dear children? Right. Tan inverse of square root of tan square x by 2. What do you get here? Tan x by 2. Okay, my dear children. Understood this step? Right. That is equal to x by 2 because tan inverse of tan theta is equal to theta. This is the property of inverse trigonometric function. Therefore, we got here x by 2. This is the simplest form of the given inverse trigonometric function. Right. Now come to the question number 8. Write tan inverse of cos x minus sin x by cos x plus sin x in the simplest form. Here we have to write this inverse trigonometric function in the simplest form. So let us take the given inverse trigonometric function. Tan inverse of cos x minus sin x by cos x plus sin x. This is equal to tan inverse of tan of pi by 4 minus x, because this is the formula for tan of pi by 4 minus x. Understood this step, my dear children? Right. Here I wrote the reason also here, because tan of pi by 4 minus x is equal to cos x minus sin x by cos x plus sin x. This is the trigonometric identity. By using this trigonometric identity, I wrote the previous step. Understood that step, my dear children? Right. That is equal to pi by 4 minus x, because tan inverse of tan theta is equal to theta. By using these properties of inverse trigonometric function, we get this step. Understood this step, my dear children? Right. This is the simplest form of the given inverse trigonometric function. Understood this step, my dear children? Right. Now come to the question number 9. Write tan inverse of x by square root of a square minus x square, comma, mod x is less than a in the simplest form. Here we have to write this inverse trigonometric function in the simplest form by substituting a suitable trigonometric function. We simplify this trigonometric function. So here we substitute x is equal to a sin theta. By substituting x is equal to a sin theta in the denominator, we get a trigonometric identity. That is why we are substituting x is equal to a sin theta. That implies theta is equal to sin inverse of x by a. Okay, my children. Now let us take the given inverse trigonometric function, that is tan inverse of x by square root of a square minus x square is equal to tan inverse of, we are substituting x is equal to a sin theta in this function. So a sin theta by a square minus x square. X square means a square sin square theta. Understood this step, my dear children? Right. So I wrote the reason also here. X is equal to a sin theta. We substituted x is equal to sin theta. Then we get the previous step. Understood the step, my dear children? Right. That is equal to tan inverse of, in the numerator we get a sin theta divided by, in the denominator we take a square common factor and we take it out a. From the square root we take it out, then it become a is into square root of 1 minus sin square theta. We get this part in the denominator. Understood, my dear children? Right. That is equal to tan inverse of, by striking out a in the numerator as well as in the denominator, we get the sin theta in the numerator divided by square root of cos square theta, because 1 minus sin square theta is a trigonometric identity. 1 minus sin square theta is equal to cos square theta. That is a trigonometric identity. That is why I wrote here cos square theta in the denominator. Understood this step, my dear children? Right. That is equal to tan inverse of sin theta by square root of cos square theta. What do you get here? Square root of cos square theta, cos theta. So I wrote cos theta in the denominator. Understood this step, my dear children? Right. That is equal to tan inverse of tan theta, because sin theta by cos theta is equal to tan theta. That is why I wrote here tan theta. Understood this step, my dear children? Right. That is equal to theta, because tan inverse of tan theta is equal to theta. This is the property of inverse trigonometric function. Therefore, I wrote here theta. Understood this step, my dear children? Right. That is equal to sin inverse of x by a. In the first step of this question, we wrote here theta is equal to sin inverse of x by a. So, I wrote this one, sin inverse of x by a. This is the simplest form of the given inverse trigonometric function. Understood, my dear children? Right.